Okay, problem 21 from the 2025 AMC 12A. It's another one with order triples, but there's a unique order triple AKM of non-negative integers such that this equation is equal to 964. We were asked to solve for basically this order triple, so we need to find the sum. So we need to solve for the order triple first. And so immediately what we can see is that these are finite geometric series. And so it's finite because, there's only a finite number of terms in them. It's a geometric because each term, well, this is 2 to the a plus 2 to the a times 2 to the k. So that's why we're adding the exponents. And so this is 2 to the a times 2 to the k squared. And so this would be 2 to the a times 2 to the 2k. So that's 2 to the a plus 2k. And so that's why we're getting this sort of like addition and this arithmetic sequence in the exponents. And we know that this is equal to 964. So the first thing I'm going to do is just simplify this. And so this is just going to be equal to 4 to the a over 2 to the a, factor that out, times 1 plus 4 to the k plus 4 to the 2k plus all the way until 4 to the mk over 1 plus 2 to the k plus 2 to the 2k plus all the way until 2 to the mk, because we're factoring out a 2 to the a in the denominator. And so we'll just continue simplifying. This is just going to equal 2 to the a because that's 4 over 2 into the a, so 2 to the a times, and so now we need to find the sum of these sequences. And so the sum of this numerator sequence here, it's going to be a sub 1 is just 1 times 1 minus the r, the common ratio is 4 to the k, and it's going to be 4 to the k time plus the number of terms. And so there's m of these like terms that have 4 in them, but there's also one more, so it's going to be 4 to the k to the m plus 1 over 1 minus 4 to the k, since that's also the common ratio. The formula is a sub 1 times 1 minus r to the n over 1 minus r. And so r here is 4k, n is m plus 1 because there's m of these 4 terms, but there's also plus 1, like one term in the front. And so now there's minus r because r is again 4k. And so that's the numerator. And what's the denominator? It's just going to be the exact same thing, but using 2's. 1 minus 2 to the k. And so, I'll probably move this because this is going to be one gigantic equation. 2 to the a times this gigantic equation. So now we just want to simplify this. And so this is equal to 2 to the a times 1 minus 4 to the k times m plus 1 over 1 minus 4 to the k times, and this is going to be the reciprocal, so 1 minus 2 to the k over 1 minus 2 to the k m plus 1. And so now there's a bunch of difference of squares, because you can technically write this 1 minus 4 to the k as 1 plus 2 to the k, 1 minus 2 to the k, because at the end you get, well, if you do this, you get 1 minus 2 to the k squared, which equals 1 minus 2 to the 2k, which equals 1 minus 4 to the k, because it's 2 squared. So we have that this is 1 minus 4 to the k, so we can just use difference of squares. So these things cancel. We get 1 plus 2 to the k. And similarly, we have another difference of squares here. So we're going to get 1 plus 2 to the k times m plus 1. So we get this thing is equal to 2 to the a times 1 plus 2 to the k times m plus 1 divided by 1 plus 2 to the k is equal to 964. So now we can immediately just first find a. So let's just try to factorize 964. It's going to be a 2. It's going to be 482. Yeah, it's going to be 482. There's going to be another 2. It's going to be 241. And I'm pretty sure 241 is prime. We can check it, but 241 is a prime number. 241 is a prime number. So 964 is just 2 squared times 241. So that means a is just going to be equal to 2. So we found one thing. A equals 2, because that's just the number of 2's in 264, or 964. So now we just have that this 1 plus 2 to the k m plus 1 over 1 plus 2 to the k is going to equal 241. And so this is a little bit of a harder equation to solve. And so basically the way I thought about this is, so we have this some number that's going of the form 1 to the 2 to the 1 plus 2 to the k for some k. And so we have that this 1 plus 2 to the k times m plus 1. I'm not even going to worry about the exponents for now, so I'm just going to call this like 1 plus 2 to the alpha is going to equal this 1 plus 2 to the beta times 241. And so I want to find some beta that satisfies this. That's going to look like it's 1 more than a power of 2. And so let's just try beta equals 0 because they're doing non-negative integers in the first place. Beta equals 0 gives us that this is 1 plus 1, so that's going to be 2. So this is going to be 482. That's not 1 off from a power of 2. Beta equals 1. That's going to be 3 times 241, and that's 600, then 120, then 3, so that's going to be 723, and that's not giving me 1 off from a power of 1. Try beta equals 2. This gives us 5. That's going to give us 1024, and that, or 1025, and so that looks very, very familiar because that's 1 more than a power of 2, which is 1024. So beta equals 2 looks promising. Let's say beta equals 2, and well, beta is what k was. I just used the variable to make it think a little easier. So this is basically just saying that k equals 2. So we're finding 1 plus 2 to the k times m plus 1 is going to equal 1025. And so 2 to the k m plus 1 equals 1024. And so 2 to the, we know k is 2, so 2 squared to the m plus 1, or times m plus 1, I guess, equals 1024. Now 1024 equals 2 to the 10th, so that means m plus 1 has to equal 5. So 2 times 5 would equal 10, m equals 4. So we found k and m that really satisfies the equation, and that's an order triple that satisfies this. So we know that k is 2, m is 4. Add these up, 2 plus 2 plus 4 is 8. And so it satisfies it. We found the order triple, and it's an answer choice, and it's also the correct answer.